In this video, we're going to talk about periodic functions. So they're a special type of function. Before we go into what they are, I'm going to go through a real world example of a periodic function. And if we can understand this one, then it's going to help us understand a lot about what a periodic function is. So I want to talk about this giant Ferris wheel here. It's called the Singapore Flyer. It was the largest Ferris wheel in the world. Now it's the High Roller in Las Vegas. But I linked it to a video of someone that has videotaped themselves riding entirely around the Ferris wheel. And basically in this video, they speed it up so that it takes 60 seconds to get around here. So that's the only thing we really need from the video. Otherwise, it's cool to watch. So I want to sketch a graph that models the height of a rider on this Ferris wheel. So we need a bunch pieces of information. So one piece of information is how long it takes to get entirely around. So it takes longer than 60 seconds. But we're going to use the time in that video. So that video says that the entire way around the Ferris wheel is 60 seconds. All right, so if we start here and we go around, that's 60 seconds. We also need to know about height. We need some dimensions of this Ferris wheel. So just from Google, I found that the highest point of the Ferris wheel is 165 meters off the ground. So from the top all the way to the ground, which is about here, is 165 meters. So we know that. And then we also know that the diameter of the wheel is 150 meters. So if I draw that right on the wheel here, the diameter, so all the way across, is 150 meters. So we know a Ferris wheel, the wheel part doesn't just sit on the ground. There needs to be some sort of like stand that it's on so that riders can get on and their legs aren't scraping against the ground as they go around. So this makes sense that the entire height of the wheel is 165. I mean the whole ride, the Ferris wheel, and just the wheel itself, the diameter is 150. So that means we can figure out what this little stand must be. So what must be the distance from here to here? So from the ground to the bottom of the wheel. Well, it has to be 15 meters. I'm going to do that in red because I think the blue is hard to see. 15 meters from here to here. And it has to be 15 meters because 15 plus 150, that's what's going to give us 165. So just from, to make it super clear, just from here to here, the stand must be 15 meters. And the rest of the way is going to be 150. So we should now have enough information to graph it. So let's do it. So before you graph a periodic function, or you have no idea what a periodic function is, before you graph any function, if you're graphing it from just information listed from a real world example, the easiest way to do it is to make a t-table first. So let's figure out what heights a rider would be at certain times. So this is just a little bit of problem solving. So let's assume that the rider gets on at t equals 0 seconds. We don't have to assume that. We could say that the time starts when they're about quarter through, but let's just make it really easy for ourselves. So we're going to assume that the rider starts here at 0 seconds. So I've already divided this up. One rotation is going to happen in 60 seconds. So let's figure out where the rider is going to be at all these different seconds. So we're getting on the ride at 0 seconds. How high is this rider off the ground? Don't tell me 0 because their feet are not exactly on the ground. They're on this little stand thing, and that is 15 meters high. So at the time of 0, their height in meters should be 15. So we're going to start here. So it might be too hard to figure out where they're at 15 seconds, 30, 45, 60, but we can just fill out what we do know. What's the next easiest one to fill out here? Well, here's where the rider gets on at 0 seconds. And in the video, it takes 60 seconds to go around. So at 60 seconds, what height should the rider be at? Well, they should have returned back to the bottom. So their height should be, again, 15 seconds. Let's pick the next easiest. Well, we know how high the rider would be halfway up, so that would be half a minute, so 30 seconds. So what would their height be all the way to the top? It's not 150, it's 150 plus 15, so it's this 165. So their height right here is 165. So I'm going to put that at 30. And at 15 seconds, that's halfway between 0 and 30, so at 15 seconds, they're here. What height is that? Just a little bit of problem solving here. Can you figure it out? Well, this height in the middle is going to be half the diameter, so half the diameter here, which is also the radius, plus the height of this stand. Halfway up is going to be, let me show you what I mean. Halfway up is going to be from here to here, and then plus from here to here. So we know down here is 15 meters, and we know half the diameter would be 75 meters, and so all we have to do is add those together and we get 90 meters. So at this point here, the rider should be 90 meters above the ground. How about at the 45 mark? So we start here at 0, 15 seconds, 30 seconds, 45 seconds. Well, it's the same as this height, so it's again going to be 90. So we're going to put 90. Now we have everything that we need to be able to sketch this thing. We've got a bunch of points. We know time's going to go on the x-axis. Height's going to go on the y-axis. We're not going to freak out about scale. We're just going to sketch it really quickly. But before we do, I want to sketch one more rotation. So this represents one rotation around the wheel. It starts at 0, goes around. After 60 seconds, we're back. I want to go around another 60 seconds. So if I were to make a new x value, if I'm just following this, I know I want to get up to 120. And the pattern here is add 15 seconds, add 15 seconds. That's what we decided to divide it into. So the next would be 75 seconds, and then 90, and then 105, and then 120, and we've made it around again. So I'm just going to continue this t-table here. Okay, and again, I just got these seconds from just following the pattern. Add 15, add 15, add 15, add 15. So let's fill in the heights. Okay, this looks difficult, but it's really not if we understand what's happening in the Ferris wheel. Okay, so from 0 to 60, we've gone around, all right? And so now we're at 60 seconds. We're back on the ground floor of this Ferris wheel. Now we're going to go up again. So at 75 seconds, we're going to be at the quarter mark again. We know what that height's going to be. It's going to be 90. So we're going to write out 90. And then, so we've gone 60 seconds, 75 seconds, here's 90 seconds. Now we're at the top. What's the maximum height? It's 165. And then hopefully you're just seeing the pattern here. Then next we're at 105 seconds. That's a quarter of the way down, and we know that height's 90 again. And then at 120, we've gone all the way around twice, and we're back on the ground floor. So we're back at 15. So let's sketch this thing. On the x-axis, we have our time in seconds. So I'm just going to put t. And on the y-axis, we have our height. I'm going to come up with a super quick scale. We're just going up by 15 here. So I'm going to say every, let's say 2 squares is 15. I think that should be good enough. Maybe every 3 squares to make it a little bit easier. So every 3 squares is going to be 15. So, oops, I don't want that. I want this. Okay, so I'm going to say this 15. 1, 2, 3, this is 30. I'm going to pause the video, just you guys can do it on your own. I'm just going to go every 3 squares is 15. Go for it. Okay, so if you follow the same scale as me, it should look something like that. You can put in the 15 if you want, and the 45 and all that business. Okay, for the height, when we're sketching periodic functions, we're just typically going to do a quick sketch. But I'm going to do a proper scale just so that you can see the shape of this thing. So I'm going to do a proper scale this one time. So we're starting, or the first value we have is 15, and then we're going up by 75 to get to 90, another 75, another 75. So we're going to increase by 75. So I think a scale that's going to work is if we just go up by 15. So that's what I'm going to do. So every 1 square is 15. So every 2 squares is 90. So I'm just going to do that quickly, and then you guys can just pause the video. That's a 60. I'm going to make this pretty. Okay, pause the video. Just add the scale in on your own. All right, ta-da, we're done. Okay, so we're just doing a proper scale this one time so we can take a look what this thing looks like. And now we're ready to graph. So we went up, we said 3 squares was 15 in this scale. We said 2 squares was 1 square was 15 in this scale. Let's start plotting. So our first point is at 0 seconds, the person riding should be at 15. So there's our first point, 0, 15. And the next one is at 15 seconds, which is here, our rider should be at 90. So there. And at 30 seconds, our rider should be at 165, which is exactly in between 150 and 180. So sketch the rest of these points on your own and then press play on the video once you're done. Ta-da! This is about what it should look like. It looks like two kind of pointy pyramid type things. So we're going to connect them, but before we connect them, we got to figure out, should I connect this with a curve or lines? It looks like this is all just linear, 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 linear. So go back to the Ferris wheel and let's just figure out, is height increasing linearly? So if you can understand this is going to help to understand why this curve looks the way it is. But take a look at this guy starting right here. We're going around this way. Is his height increasing linearly? So in like a constant rate. So at the bottom here, we're at the bottom of the circle. It's barely increasing for the first few seconds, and all of a sudden, whoop, it increases very quickly in a very short period of time. Just thinking about rate of change, which we learned in grade 9, or slope, or if you learned it in grade 10, this one is so much more shallow than this one. So here, his height is, or her height is barely increasing, and here it's increasing very quickly. Whoop. So that means that we cannot connect this with straight lines. This must be with a curve. So to connect it, it's going to look something like this. Ta-da! So you'll get better at graphing these because we're going to be sketching this quite a lot, but we're going to connect this with a curve to show that height isn't increasing in a constant manner. Then it would be just lines. So there's a reason why I brought you on this whole Ferris wheel excursion, which is that a Ferris wheel is an example, or the height of someone on a Ferris wheel is an example of a periodic function. So a periodic function just means it has repeating y values in a pattern over and over and over again. That's why I had us graph this 2 times, because this person can go around over and over and over again, and their height is going to follow the same pattern. So it's a function because it passes the vertical line test, and it's periodic because the pattern happens over and over and over again in the exact same way. So here's that definition one more time if you need it. A function is periodic if it has a pattern of y values that are repeated over and over and over again as the x values change. So take a look at these 3 graphs. Which ones are periodic? So let's take a look at the first guy here. Does this have a pattern that repeats over and over and over again in the exact same way? Well, you can see the pattern in many different ways. Some people might see the pattern starting here. Some people might see the pattern starting here. I see it from here. So this is the pattern that I see, just like this. And it is exactly repeating over and over and over again. So this one is periodic. Let's try the next one. How about this guy here? Does this guy have a pattern that's repeating over and over and over again? And by pattern, I mean in the y values. Are the y values the same over and over again? So here I see one little hump here. Is this little hump the exact same as this one? No, it's smaller. And then it gets smaller again and smaller again. So the y values aren't repeating, they're changing. This y value goes all the way up to 2 and down to like negative 1.5. And then it doesn't go up to negative 2 or positive 2, and it definitely doesn't go down to negative 1.5. So this is not repeating, so it's not periodic. And how about this guy here? This guy looks like the Ferris wheel, except opposite, where the person's starting at the top of the Ferris wheel and going down. So is this guy periodic? Is there a pattern that's repeating over and over again in the y values? Well, it depends on where you see the pattern. Do you see it starting from here? Let's check. Here's one pattern, and here's the exact same pattern again, and the exact same pattern again. So this one is periodic. So you can think of the word as periodic just meaning repeating. So a word that I want to talk about for periodic functions is a cycle. A cycle is one pattern, and it's the smallest pattern that you can find. So for example, this guy is not periodic, so we can't find one cycle. But here we can find one cycle. So here's what I mean. I want to find one pattern here. So someone could say that it's this. Don't copy this down. I'm going to do. That's one. And that pattern, this double thing, is going to continue. There's going to be one here and there's going to be another one there. It is going to continue. But by a cycle, I mean the smallest pattern that you can find. So instead of highlighting two of those things, I'm going to highlight just one of them. I'll show you what I mean. Here we go. So there's multiple answers for what the cycle is. It depends on what you see. So I, for example, see this. So I see it starting from the bottom peak, going up and down. So to make sure that you've got one cycle, ask yourself, could I take this and like take a copy and paste it right there and hit copy, paste, and put it right there, and it would be the same? Yes. Someone might have seen a totally different cycle. Someone else could say, Miss, I see it starting from up here and going down and back up. Are they right? Can I copy and paste this dip right beside? Here we go. And yes, it repeats again. So yeah, that totally works. Some people might have seen it from here. Let's pick red. Maybe starting right at the x-axis and going down and back up to the x-axis. Can I copy and paste that cycle over and over again? So if we got do, and then it's going to happen again, do, and the other side too. So a cycle can start and end wherever you see it, as long as it's one complete pattern. So if we were going to quickly find one of the cycles in this last graph here, maybe you see it as this. That's the pattern that repeats over and over and over again. Or maybe you see it as this. That's the pattern that repeats over and over again. As long as you realize that one cycle is one pattern, it can all be correct. So there's three important terms that you need to know when it comes to periodic functions: period, amplitude, and equation of the axis of the curve. I'm going to go through these quickly, but you probably won't, it won't sink in until we do an example. So I'll run through them quickly, then we're going to do an example. A period is the length of a cycle. We just practice how to find a cycle. A cycle is just one pattern. So the length of that pattern, that is the period. And it doesn't matter which cycle you pick, it's all going to be the same length. So if you had picked this green guy here, the length of that cycle is 2. And if you had picked your cycle here, the length of this cycle is also 2. So it doesn't matter which cycle you pick. It's always going to have the same length. That's called the period. The equation of the axis of the curve, there's a formula for it, but it's just the horizontal line that cuts the graph completely in half. And the amplitude is the distance from that middle line all the way to the top of the curve, or the middle line all the way to the bottom. Because it's the middle, the distance from the middle to the bottom and the middle of the top should be the same. There's also a formula for that one. Let's go ahead and learn these through an example, and we'll come back. So we're going to do some flipping back and forth. because for this graph, we've got to find the period, the amplitude, and the equation of the axis. So we'll flip back and forth to remember what everything is. But first of all, is this a periodic graph? Well, yes, this one we've seen before. This has a pattern that repeats in the y values over and over and over again. So I'm going to immediately highlight one cycle. Doesn't matter where you see your cycle, as long as you're just highlighting one. I'm going to just do the original one that I saw from here to here. So the period from our definition on the other side is the length, let's do it in pen, the length of one cycle. That's going to be the period. So the question is, how long is that? So the way I have picked this cycle, it's kind of difficult to tell what that number is. Is that negative 0.5? Is that 4.5? Remember how I said you can find cycles in multiple ways, or you can find it starting and ending in different parts of the graph. If this doesn't work out nicely to find the period, pick a different cycle. Like something like this, for example. Let me pick a different color. Let's do green. Okay, so there's a cycle, and I'm going to pick this guy as my cycle, so here's my period. Okay, this one's going to be easier to tell how long this cycle is because it starts right at the corner of the grid. So this guy starts at 2 and it ends at 8. So how long is one cycle? It must be 6. So the period in this case is 6 units. So the next two things we have to find are amplitude and equation of the axis. So I'm going to skip amplitude and we're going to go right to the equation of the axis, then we'll come back. The equation of the axis is just what line is in the middle is going to cut this graph completely in half horizontally. So because it's a horizontal line, it's going to start with y equals. So the line that's going to cut this thing in half is always going to be called y equals something, because any horizontal line is called y equals something. This line here would be y equals 1. This line here is y equals 2, y equals 3, etc. So we know that the line is going to start with y equals. Now I just got to figure out what's in the middle of this graph. The highest number on this graph is y value is 4. The smallest is negative 3. What's in the middle of 4 and negative 3? How do we calculate that? Well, if we're finding the middle of two things, we're just looking for an average. If you got two tests, you got one of them was 70% and one of them was 80%, you want to know what was your average or what's in the middle, you'd add them together and divide by 2. So if you want to find the middle of 4 and negative 3, that's exactly what you're going to do. You're just going to add them together and divide by 2. You're just finding an average. So our maximum was 4. Our minimum was negative 3, so we're going to add those together and divide by 2. So this is going to be positive 1 divided by 2 1/2. So y equals 0.5 is our equation of the axis of the curve. That is what's going to cut it in half. So let's sketch that on there, make sure it looks right. So I know 0.5 is about here, so I'm just going to do a dotted line across here, and that does look like the middle of the graph. So we've got two of these words down. Period, we know that that's length of a cycle. We have equation of the axis, that's just what's going to cut it in half. That's going to be the average. The last thing that we're asked to find is the amplitude. So the definition is on the other page, but let me give it to you again. The amplitude is the distance from the middle to the top of the graph, or from the middle to the bottom of the graph. Either one, it should be the same, because if it's truly the middle, then it should be equidistant to the top and to the bottom. So there is a formula for amplitude. We'll go through it, but if you can just count it by counting the squares and just figuring it out, that's so much faster. So if I were to count this height here from the top to the middle, it would be 3.5 squares. 4 to 0.5 would be 3.5. So the amplitude is 3.5. And let's just check it here. We're going from negative 3 to positive 0.5. So it's 1, 2, 3.5. So the amplitude is 3.5. I'm just going to copy it onto here. So our amplitude, we're going to use little a for amplitude, is 3.5. On some graphs, it's really hard to actually see what the amplitude is. So there is a formula for it. So let's take a look over here. Whoops. All right, so the equation of the axis of the curve, that's the middle. We knew this, but there it is for you. We're just going to find the average of the max and the min. Max plus min divided by 2. The amplitude looks exactly the same, but with a subtraction sign. So I always remember, I know the axis is the middle, so that's going to be the average. And the amplitude is the other equation. So for the average, we add. For the amplitude, I'm going to subtract. So we figured out just by logic that the amplitude was 3.5 just by counting the squares. Let's make sure that the equation works for that. It gives us the exact same answer as well. So I'm going to copy the equation. The amplitude is equal to the max minus the min divided by 2. So let's see if we get the same thing. The max is 4. The min is -3. Divided by 2. I'm going to finish it off over here. So we have 4 minus -3, so that's going to be 7 divided by 2, which is going to be, guess what, 3.5. We get the same answer. So if you can just figure it out visually, that's fine. If you need the equation, now we have the equation. So the difficulty with learning periodic graphs at first is just all of the vocabulary that goes with it and the new concepts. So the 3 new concepts that we learned, well, we talked about a cycle, so that's just one pattern. The period is just the length of one cycle. The equation of the axis is the midline, with the line that's going to cut it completely in half. And the amplitude is the distance from that midline to the top or the midline to the bottom. So now that you have that, plus you have some formulas to help you out, I want you to try this graph completely on your own. So I'm going to zoom in on it so that you can see. I want you to pause the video. I want you to come up with the period, the amplitude, and the equation of the axis. I'm going to just show you the answer once you come back, and we're just going to talk about it a little bit. So pause the video and try it on your own. So if you're back, you should have gotten a period, an amplitude, and equation of the axis on your own. So I'm going to reveal the answers. Ta-da! Did you get the same thing? The period that you should have gotten is 3 units. It doesn't matter where you started and ended your cycle, as long as it was one complete pattern. So maybe you started it from here. Maybe you saw this was your cycle from here to here. If you saw this was your cycle, to count the length of it, we started at -1 and it ended at 2. So that length is 3. The equation of the axis you should have gotten was 2.5. So that's the middle. To find the middle, we're just going to find the average of the max and the min. So when we add 5 plus 0 divided by 2, we get 2.5. Just like that. If you didn't use the formula, you just remembered, I just have to find an average, perfect. Or maybe you were able to visually see exactly what was in the middle and you were able to get to that right away. That's also perfectly fine. Now let's talk about amplitude. So the amplitude that we should have gotten was also 2.5. Remember that amplitude is just the distance from the middle to the top. So if I calculate the distance from this midline to the top or this midline to the bottom, it should be 2.5. If you want to double check with a formula, you can. Here's what the formula would look like. It's not the average, it's the one with the subtraction. So max minus min divided by 2, 5 minus 0 divided by 2, our amplitude is 2.5.